All right, hello everybody, and welcome to our first lesson on Pythagoras. Okay, what is Pythagoras? Well, Pythagoras was a person. This dude here on the left, that you can see in the stone statue or marble. I'm not sure what it's made out of. His name was Pythagoras, and he was from Greece. Where modern day Greece is, and he lived around 2,500 years ago. So he lived around 500 BC. Okay, so that's 2,500 years ish. 2,521 years ago, roughly. And he is very famous in maths because he created something called a theorem, which is a funny or a fancy way of saying a rule. Okay, so Pythagoras noticed something. Now, here's an interesting tidbit. Okay, people think that Pythagoras is the one who created this, but they've also found out that the Chinese may have discovered it before him or at the same time. That's an interesting story that I'll hopefully tell you in class someday. But in Europe and in America, we often say that this is Pythagoras' discovery. So Pythagoras discovered, a rule that involves right-angled triangles. Okay. Now, what I'm going to draw now is I'm going to draw a few triangles, very roughly. Okay. They're very roughly drawn, so apologize for that. And I am going to put. You're going to see that I am going to put a little box down here like this in each of these corners. All right. Now we have learnt, you may have forgotten, but we have learnt that these little boxes, these little orange boxes in the corners that I'm going to draw an arrow to, these little things, they tell us that that corner is a 90-degree angle. 90 degree, okay? So those little squares mean that the corner angle like that is a 90-degree angle. And we call those right-sided or right-angle triangles, okay? So a right-angle triangle. Right angle, okay? Remember that, you won't forget it. Right-angle triangle. Now, so Pythagoras discovered that if you have a right-angle triangle and you draw squares, okay? So Pythagoras discovered that if you draw a square, and let me just get a colored pencil. If you draw a square on each side of a right-angle triangle, okay? I'm just going over it with the pen. So a square, remember, a square is all the same sides are equal. So if this was 10 centimeters, this would also be 10, and this would also be 10, and this would also be 10, okay? And down B might be 8, okay? So B might be 8 centimeters. So this would be 8, this would be 8, this would be 8, and this would be 8. And this one over here, A, this might be, for example, 6, 6, 6, 6, and 6. And inside of that, we have got our right-angled triangle. You can see the little box. Now it's written in black, but that's okay. So we have our triangle inside of those squares, okay? So what Pythagoras figured out was if you draw a square on all three sides of the triangles and you take those squares and you add up the square, the area of the square. So here you have A squared, okay? So that's the area of the square A. So let's say that was 6, okay? Let's say that was 6 centimeters. That would be 6 squared, which is 36, all right? And then we have B squared, which we said was 8, okay? 8 centimeters. So that would be 8 squared. So 8 multiplied by 8 is 64. And then we have c squared, which we said c was 10. Okay, so that's 10 squared. 10 multiplied by 10 is 100. Now, what Pythagoras figured out was if you drew boxes, if you drew squares on each side of the right angle triangle, and that you added A, and then you added the B, you added those two together, this one and this one. If you added those two together, you would get the same as C. You'd get the same as C. All right, and let's see if that's true. So we figured out that A squared is 36 and B squared is 64. And if we add those together, we get 100, which is the same as this. So that's what he figured out. Now, let me just show you something a little bit different, okay? Let's get rid of these boxes for a second. And let's look at a triangle, okay? So this is a right-angled triangle. We know it's right-angled because it has this, we know it's a right-angled triangle because it has this little box, which tells us that this is 90 degrees. Okay. And they have labeled each side of the triangle. So here we have A, here we have B, and here we have C. Now, we don't know how long each side is. We don't know the measurements of each side. But the rule of Pythagoras, okay, Pythagoras' theorem, is that if we have A and we square it, okay, which means we multiply it by itself, we did that on Monday, and we put an equal sign, and we have B squared and C squared. So if we have A squared, that's this side, the length of this side, okay, the distance from here to here, the length of that side. If we have A squared, that will be equal to B squared, which is the length of this side, added to the length of C squared, which is the length of this side, okay? So we have three sides to a triangle. And if we square A, we get the same result as if we square B and C and add them together. Now, here's a key term that I haven't maybe mentioned to you before, so it might be brand new to you. This is A is the longest side of a triangle. You can see with your eyes that it's the longest. You wouldn't have to measure it. If I said to you which side is the longest side, you would say A. You can just look at it and know. So the word we use to describe the longest side is called a hypotenuse, like hippo. Hypotenuse. Okay, the hypotenuse. For short, you can just write H. Okay, so here H is A. Okay, A is the hypotenuse. Now, what I'd like you to do is I would like you to answer these questions. So what is the length of the hypotenuse in each of these triangles? I always forget to click on these. There we go. So I'd like you to write down, I want you to pause the video and I want you to write down what is the length of the hypotenuse in each of these triangles, okay? The hypotenuse. The hypotenuse, and go back, if you don't remember what the hypotenuse is, just go back about 30 seconds. So I want you to write down, pause the video and write down what's the length of the hypotenuse. Okay, hopefully you have written these down, and if you were stuck, hopefully you went back and just watched it one more time. So the hypotenuse is the longest side. So which is the longest side of this triangle? We have 3, 4, and 5. Well, 5 is the longest side, so the hypotenuse is 5. And over here, the hypotenuse is the longest side, and that's 10. So this is the hypotenuse. Whereas over here, this is the hypotenuse. And over here, the hypotenuse is the longest side, so it's 8.6. So it's this one here. Okay. So now, the next sum that I want to do is I want to have a look at this one here. All right. So we learned that the theorem of Pythagoras is that when will I learn? We learned that the theorem of Pythagoras is a squared equals b squared plus c squared. Now, here we have a bunch of right angle triangles. All right. So A is the hypotenuse and B is one of the other sides. It doesn't matter which for the moment. Okay. And C is one of the other sides as well. So what I want you to do is I want you to pause the video, quickly sketch out these, and then I want you to label which of these is A, B, and C in each of the triangles. I'm going to do the first one for you. So here, the first one, P, this side here, this is A, okay? And then this side here we can call B, and this side here we can call C. So I want you to write out the other two and then label them. So pause the video now. Okay, so hopefully you said that this side was A, and then you can say that this side is B and this side is C. And over here, this side is A, this side is B, and this side is C. Okay? Now we want to figure out what P is, what Q is, and what R is. Now, the rule of Pythagoras is up here. A squared equals B squared plus C squared. Well, in this sum, they have already squared the numbers for us. So we don't need to do any multiplying, which is great. So the first thing that I'm going to do is I'm going to write down here A squared equals B squared plus C squared. Now, do we know what A squared is? No, we don't. So I'll just leave it as A squared. Do I know what B squared is? Yes, I do. It's already told me that B squared is 28 centimeters squared. All right. And then C is 16 centimeters. So I'm plussing C, so I'm plussing 16 centimeters squared. Okay, if I want to figure out what A is, I just add these two together. So A squared is equal to 28 plus 16. So I add on the 10, that makes 38, and then I add on the 6, which makes 44. So 44 centimeters squared. So A is 44 centimeters squared. Okay, so I want you to try and do this second question. I'm going to change the color of my pen. I want you to try and do the second question here, just like this one. Okay. Hopefully you've had a go at it there. Let's check our answers. A squared, and remember I write down this rule, equals B squared plus C squared. Now A squared, we don't know what it is. We know that B squared is 23 centimeters squared. And if we add that to C squared, which is also 23 centimeters squared, so if we add these two together, we will figure out what A squared is. A squared is equal to 46 centimeters squared. Now, the last one is a little bit different. So take a moment, have a look at it, and see if you can figure it out. Okay, so remember A squared equals B squared plus C squared. So A squared, we know what A squared is here, so we write down 70 centimeters squared. We know what B squared is, 20 centimeters squared, but we don't know what C squared is. We don't know what that is. But we can look at this and we can see, okay, what number added to 20 centimeters squared, what number added to 20 centimeters squared would give me 70 centimeters squared? So it would be 50 centimeters squared, wouldn't it? So if I added 20 centimeters squared to 50 centimeters squared, I get 70 centimeters squared. So all I did here in my head was I figured out the difference between 70 centimeters and 20 centimeters squared. So I subtracted them. So in my head, I went 70 minus 20, and that gave me 50. All right, so that's today's sums. We're going real slow at this. Let me know how you got on. Let me know if you got stuck with any of it. It is a bit tricky. We're going to be doing this for a little while. It's a really important theorem because you will use it not only this year, but you'll use it every year you're in school. So it's really important that we get it right the first time, especially if this is the first time you're doing it, and I think it might be. So do let me know if you're stuck.